welcome to everybody. It's with us tremendous pleasure that I welcome you to the second day of this ATAL FDP. We want to welcome you warmly and hope that you enjoy this session. So our speaker for today's session is Dr. Krishna Pratap Singh from IIIT Allahabad. So Dr. Krishna Pratap Singh actually is currently working as an associate professor in Department of Information Technology, IIIT Allahabad. His area of specialization is now machine learning and deep learning. So his master and PhD from IIT Roorkee, and Dr. Singh had many funded projects, and he has awarded 5 PhDs, and currently 6 PhD scholars are working under his supervision. He also performed many administrative responsibilities. He has published a number of research papers in international journals and the conferences. And the citations of his papers are 1079 and H index is 10 and the I-10 index is 11. So now let's welcome to Dr. Krishna Pratap Singh, who will deliver today's lecture on safe machine learning or deep learning application in NLP and computer vision.
Well,
yes, so let's start.
Thank you, Dr. Anju, for such a nice introduction and inviting me for this, for sharing this talk on machine learning, deep learning, and its application. So good evening to everyone, and I will be happy that if anyone have any question, then anytime you may raise a hand and ask, because it's a 2-hour long session or more than that. So instead of this monotonic, if you ask at an in between, it will be better so that I will feel engaged. Otherwise, it will be monotonically, one-sided, I will deliver. Well, so I will share, and since this talk is on machine learning and deep learning, I don't know about the audience what they know about these things. So in the 2 parts, what initially I thought to be go in advance, but I will go in 2 ways. In my talk, one half I will talk about some basics of ML and deep learning. And second, I will talk about the safe part, which I have put it down in my topic. And then in 1 hour, I will introduce what are the important issues which needs to be. See, so that way I am planning to go. 1 minute, just I will check out. Once my slide is visible, then let me know. Is it visible?
Yes, sir.
Okay. Okay, so my slide is now just I'm checking in between if I have to share. Am I able to change this or still same slide is visible? I don't know. Okay. This my screen is visible or not?
Yes, the screen is visible.
No, it's blank one right now I'm sharing. Or topic is visible.
Yeah, your topic is display here, safe machine learning and deep learning.
Okay.
First slide of your topic.
Okay, just a minute. Okay, so that part means in between I have to change and go. Okay, that I will do that. Okay. So the topic suggests the safe machine and deep learning. Safe means what I am going to cover is secure, accountable, fair, and efficient. So nowadays this is a big word. Everywhere we are talking about this machine and deep learning. Am I audible properly to everyone or? My video is also on so that.
Yes.
Am I audible? Audible. Okay, thank you.
Yes.
So let's start with this. What is machine learning? And why we need this machine learning nowadays? Every time we all are feeling that we have a huge data sets. In any domain of application, we have a data set. And we want to infer from these data set X, you can say we want to infer some knowledge which may help us to do our task. So what we are doing in this machine learning, like what happened with the human being? Human being have this capacity to learn by seeing the data sets. But we are talking about the program or what is this machine learning is a you can say a function or computational program which can take a data and learn something meaningful, and then for any new data you can predict that what is going to happen. So what it says that the generic definition is learning is a process where the improvements happen. The same philosophy you can see the learning what it means for the human being or for kids. When we say that a person is learning something, so what we do that we observe at a time t, and then after certain time t+1, and then we measure the improvement. And then we say that, okay, if it is happening, then we can say a system or person is improving. What is happening with this machine learning? If you see this picture, one robot and one kid, we all have that observation regarding how these kids are learning. But what we are trying to do nowadays, we are making this robot to learn, to do a lot of tasks, whatever as a human being we can do. We want that robot to learn, do the task. But the question is how it is possible? What's the meaning of this machine learning? If you just recall your observation for kids, how the different kids learns. If you observe a 2 years kid, he or she is able to see the thing, but not able to know that what that picture is. As a parents, we teach them, okay, this is the water, cat, dog, mummy, papa. So we are giving the label kind of information, and that kids is able to see the things, but not able to speak. But slowly after certain time, 6 months, 1 year old kid, 2 year old kid, 3 year old kid, 5 year old kid, and 5 years onward, in fact 3-4 years onwards, we observe that kid is able to speak well also. Initially very less, he or she is not knowing the language, but eye is there, so he or she can see. So what has happened there, you can see through the eye is what the computer vision we do. The computer vision task as a human being, what we see or observe, the same kind of things we talk about in the computer vision. And the language, you know that how the kids learn. The 1 year old or 2 year old kid is not able to do that. Form the language sentences and speak or communicate there what he or she is seeing. Even 5 years kid, he can speak. 10 years, 20 years, then you observe that the synthesis of sentences comes out later on. So the same thing happened what in the research domain of machine and deep learning. A lot of research has been done on the vision part, computer vision part, and also in the this NLP part, natural language processing. But you can correlate this problem as same how as a human we learn. What we are doing that we all are seeing this robot and making this robot to see the things as a human this kid is seeing, speak as this kid is going to learn and speak. And that's what in the whole machine and deep learning tasks we do that. We have a data, we gather the data and we try to make a model, and then we put that model in robot to do the task. So how we define this machine learning is it's a computer program. It's set to learn from experience E. Experience E means data set. What the data set you have. For example, one data set is that for kid we are saying, look, this is the image of cat, this is the image of dog. So as much as the image of cat and dog we show to the kids, after certain time that kid is able to recognize. So as the experience means data set we increase, that kid learning is happening. Same way for the robot, our task is we have a data set. We have, like, for example, image, and then we have the label or tag for that image. OK, we have a data set X. This is the image of a cat, and then Y, which tells that Y may be cat, maybe dog, something symbolic. So we want with respect to data set, some class task T and performance measure P. If it is performance and task as measured by P improves with data sets, that's what the machine learning. The whole idea of machine learning is we have a data set X we have corresponding label Y. This is the example of supervised learning with what I am giving. Means we have image and we are telling that, okay, this is the image of cat, this is the image of dog, this is the image of cat, variety of cat, variety of dog. So many data set we may pass and with the label. And then we try to learn a function, you can say fx, which is basically a machine learning model. So what's the idea is from x to fxy, we are learning a function. What will happen once we learn this fx? Then if any new image comes out, then this function can tell that is it an image of cat or is it an image of dog. This is the general definition of supervised learning, a data set at corresponding level. And a lot of algorithms have been developed on top of that. One artificial neural network I will discuss for the today talk, and then you can connect with others. General machine learning part, again and again I am putting, we have a data set X, we have label Y, in between we want to learn fx. But there are a variety of things to do this, and we can classify this problem in many ways. It's not the unique way. In some cases, Y are unknown. Some cases, Y levels are unknown. Like a classroom teaching, what happened in the classroom teaching? It's a supervised learning. So classroom teaching is a supervised learning. It means we have X and we have label, and we are telling that, okay, this is the cat, this is dog. This is the supervised learning. And for such kind of supervised learning, you can see many applications like image classification. One example I am giving. Okay, this is an image of cat, this is an image of dog, or whatever. Diagnostic, huge application of supervised learning you can see in the diagnostic. Means what is happening? Nowadays in the medical domain, huge applications are coming. And either X-ray image or any MRI, what we do after taking these images with the report, that radiologist will give the report, and what we do with that, then on the basis of that recommendation, doctor say that a particular, what is, suppose it's a MRI of or X-ray of your bone, then he or she may recognize that there is a fracture or not. So what is happening, that can we make a system automatically pass the X-ray and then it may automatically detect that, okay, if there is any damage or any disease. Many research paper you can see for this chest X-ray and putting that it's pneumonia or COVID. During COVID period of work has been done. So what happened in the supervised learning part, we train our model or we learn this function. Okay, in the historical data, we have X, we have Y, and then what we do, we learn a function which can say that, okay, once a new X-ray image comes out, then that function or that machine learning model will tell you, is there any disease or not. So this is the diagnostic system. It's a huge application in medical domain. A lot of things are coming. Customer retention, looking at your hotel chain. Again, everywhere you can see that we need the data, so that we can build up a model. Because X and Y, X is a data sets, Y is the corresponding label. And if you don't have the data, we cannot play with this supervised learning model. So many applications, customer retention, identity fraud detection, either credit card fraud or any other cases. If you have a data sets X and corresponding level, fraud or not fraud, then we can build up a model. So these all are what is happening. This is the classification problem, supervised learning with classification problem. So in this supervised learning, X and Y both are known. X is the data, Y is corresponding level. And what is classification? The supervised learning may be a two kind. One is classification. Classification means what happened. This Y have a discrete value. Discrete value means it may be a cat and dog, so two value possible. Or it may be diagnostic or 3 or 4 diseases you want to predict from the data set. So this y value for a data set, if it is a discrete and countable then we can build up a classification model. And there are so many techniques for classification like logistic regression, artificial neural network, support vector machine, deep learning. So many methods for classification exist. And I will discuss after some times. So this is the part of supervised learning where the labels are finite and discrete. Another class of problem is regression. Regression comes out in the case where X is a data set and corresponding Y. In both cases, Y is known. Y is a continuous value. For example, if you see share market forecasting. So share market value is, you can say, suppose Nifty, if you are familiar, then some value are 12,000 or 15,000. So next time it may be, it may take any value after a certain time. So this is what, if Y is a continuous, it's not a class, then it becomes a regression problem. But same market forecasting, if you are saying that I want to predict today market will go up or down. So if Y you are saying up or down, so only two possibilities, then it becomes a classification problem. So for classification, there are again, you can use so many methods, either support vector regression, simple linear regression, or you can use deep learning model, and also with certain conditions modification for these tasks, either weather forecasting, advertising popularity prediction, estimating the expectancies. So there are so many applications of supervised learning you can see. So only thing is that to develop any supervised learning model, you need a data set. You need X and corresponding label. If you give wrong label, model performance will be poor, and that I will discuss the safety issue, especially in the many application domain. If someone will corrupt your Y value, then the performance of all models will degrade. This is one of the challenge. But for the supervised learning, we need a data set. Only X, only images, because we all have the images. If I ask how many images on your mobile phone right now, so everyone can say at least 400, 500. But if you give that image to your friend, he or she may not be able to recognize who is there in that image. You know that, but you have not labeled that he or she is your friend, son, or something. So label means telling that, okay, what is there, what kind of things are there in the images. So most of the data sets, we have a data set, but labels is very, very important. And most of the time, this, if Y is not known, it's challenging. Even for diagnostic, for training purpose, initial data sets for any X-ray of chest, in the data set, you have a data which tells that, okay, this is the chest data, X-ray data, and in this case, there is a pneumonia, in this case, there is a COVID case, and in this case, it's a perfect. So all these levels, initial data sets are known. If not, and only X-ray without any labeling, it becomes difficult how to develop a model. So that scenario is different. In the supervised, X and Y both will be known to develop a model. So like a teacher's training. In the classroom, we are teaching. So we know that what needs to be taught, and accordingly student build up. So this kind of supervision we are giving to the students to learn. Now like Eklavya, what he did, he learned himself. So no label, no guidance. In that case, only X is known, only data, only image in your phone is available, but you want to get some information. How to do that? And what are the tasks you want to do? So playing with this only X data without any label also have a huge, because such data sets are available in a huge numbers everywhere. Data sets are available, but label data sets are less. So supervised learning class, we need a label data. Okay, this is one class of theory, so many algorithms are there. But there are some applications are some particular domain where huge unlabeled data sets are available. We need, because labeling of a data is a costly part. If you put any doctor or a radiologist to put in an image, be it a fair image or not, he or she will charge. Who will do that? And if someone layman will do, and he or she will not do perfectly labeling, then your model performance will degrade. So these are the pro cons for the supervised learning, but how to do if X and Y both are available? This is what the supervised learning. In unsupervised, again, so many applications, and we have huge number of data for this. Even I will tell you, but we don't have some applications where data set you can simulate or generate, and then you can build up a model. Later on, I will tell you that ANN people have built up to solve the differential equations. They have created a data and more from the model, and then they try to solve a solution for that. So in the unsupervised learning, also it comes out like many application domain, a big data visualization, meaningful compression, structured discovery, feature. So it's like no one is telling what is there, and you learn by your own way, like Eclabia, anything. So you have to fix some target, what you want to do with the data. If labels are available, some kind of target is known what you can do with the data. But if labels are not available, so you have to see that what you want to do with that data. You want to reduce the data, you want to do meaningful compression, structure discovery. Okay, so targets we need to do to fix it, and then accordingly we can learn with this unsupervised learning. Nowadays, okay, also it's a big challenge in the big data era, where everyone is talking about big data, but most of the time is unlabeled data sets. So how to play? So there are so many methods and approaches to handle with this. And recommender system, customer segmentation, targeted marketing. So many applications. We have a data and find out that okay, similar kind of people, and then getting that okay in the business implications, how we can draw using those data some meaningful information so that we can the benefit of that. So many applications, you can Google it and you know. And third way of this machine learning is reinforcement learning. So many games you are seeing, any AI games and all, or learning tasks, robot navigation, how robots should move on a path. So in that domain, people have developed a lot of reinforcement learning kind of algorithms. What it means that we do something, and whatever the knowledge you gain, either wrong or right, you give the feedback to the model again. So after certain iteration, you give the feedback. So we continue with the feedback loop to get a solution. So like robot navigation. So you want to put a robot so that let's choose the path, and if any obstacle comes out in the way, robot should not collide with that. That robot should get the path to okay without collision move to the target. So what it happens that you cannot create huge data sets only and then you can play. So in that case, robot see, and if sometimes hit it, then you give the feedback. Okay, this is there should be a penalty, and in that way you design that reward kind of function in the reinforcement learning. So huge application in such domain. Also, people are working in this reinforcement learning part. So in the nutshell, you can see in the machine learning the problem. Everywhere we have a data, we need a data, and we have to play. If Y is available, then you can go with supervised. Y is not available, then you can go with unsupervised learning. And in between, if there are like a game kind of scenario or real-time decisions, robot navigation, you may go with the reinforcement learning kind of algorithms. So what happened in the machine learning and how we design the objective functions? So for that part, what do we do and how? What if you recall the machine learning part? What we do that? Okay, we have X and Y. So suppose some value, the data set is known. Suppose like regression part or this t or y, whatever the levels are given. So let 2, this is value is, you can say 1 class, this is 3, you can say 0, 4, you can say 1, like that. So we learn fx, and what we do, whatever this fx comes out, like regression, if you know that this is the value computed through this function. So this function could be, you can say, suppose the problem, this fx, you can say w transpose x, or you can say w1 x1 plus w2 x2, for example. What it means, let your data set is like that. This is like x2 x1 and corresponding y or t I am writing here. Sorry for this change. This I am saying 10, this is I am saying 5, this is I am saying 16. Now the y value, you can say let any value, either 0, 1, 0, I am putting randomly. This is the label, this is x1, x2. 2x1 was 2, so this part you can say capital X. So the data set may have multiple features. Your data set may be like this. X have a vector kind of x1 and x2. It means 2 feature. This way, 1 feature, so one data have 2 features. So you can say 2 and 10, and another can say 3 and 5. So like this. So if there are 2 features to build up a model, you can say we need, we want to fit a linear function. So linear function means w1 x1 plus w2 x2. The x1 and x2 are data set. This way w1 and w2 are unknown. So what we want to learn, we want to learn this weight from the data set x1 and x2. This is the x, or this you can say w transpose x is a one function. Given x means data, we want to learn w such that the error between computed value of fx, w transpose x, and actual value t. T here means this y. Many references you can see people are using either t or y, same target. So one computed through this and one actual known in the data sets. So what is the idea? We want to reduce this error. This error should be minimum. In any machine learning task, this is the how you know that things are happening, or learning is happening, how you make a model. So we want for any given x, we build a fx. F is a function, you can say a linear function as a w transpose x. Then we can say this e is error function, green part, between the, this is the computed one and this is the actual one. So what is the difference error? And we want this error should be minimum. So this is the optimization comes out. Minimize the difference between the computed fx and t. So if you all are familiar about the optimization problem, what is the unknown? Unknowns are the weight w1 and w2. For in this example, if I am considering a 2-feature problem, then w1 and w2 are unknown. So this is the what in general for any learning model. Every learning model, machine learning, deep learning, or reinforcement learning, we need error function. If I'm talking about right now, supervised kind of modeling. So what we need? Data set is given, so we are fitting f, so we want to compute error. Error means what your function is giving and what target is given. That should be close or exactly same, then very good. If not, then it should be closer to the things. Then in the machine learning also we put one regularization term. In general statistics we don't put this, but in the machine learning this R have very important role. What it means and why we are doing this. For example, you see in the classroom teaching. You might or you just recall wherever you have studied that we do the training, and in the classroom training, the observation part if you do, student who got maximum marks, for example. So what you can say, he or she is maximum trained person in the class. Any degree, whatever he or she has covered. So error is minimum without R if you are considering, but at the same time, that fellow, I'm not diminishing that fellow, it's not necessary that if any real problem comes out, then or any way in the life problem comes out or competitive problem comes out, it's not necessary that the first time who will solve that problem or achieve success will be that person who got the highest mark in the classroom. Highest mark means minimum error. Whatever you are asking, he is giving the correct answer. What machine learning is saying, we are not interested only the training, the person who is trained so that every time getting 100% mark. We need a person who is trained very well, but at the same time, if new things comes out, he or she may be able to solve in a better way also. So in the machine learning, this is also the important part. This regularization is for that purpose only, to ensure that it should not be, the model should not be spoon fed. So that our part is important in that way, that spoon feeding should not be happen. Training should be good in the classroom or in the machine learning part. The model we train with the data set and we test with the data sets. So training and testing should be the balanced one. And that's why we need to put this regularization in every model, either machine learning, deep learning. This is the important part. What happened? Let's the simple example. You see the regression part. I'm assuming that you might be all are aware about that regression part. What we do in the linear regression. In any linear regression problem, suppose again, if you want to fit a two feature, it's a two dimension. So our X is like that, X1 and X2. So I can build up a model that W1 X1 plus W2 X2. So what happened? Underfit phenomena means if what we do for the machine learning, every machine learning part, if we have a data set 100 data, suppose you have in the machine learning, what we do 70 to 80% data we keep for training and remaining 30 to 20% data we keep for testing. Whatever the model, error, minimization, problem, whatever we give, we train our model in this. This is called the training accuracy. What is the accuracy? Comes out the training data, training accuracy. This is the test data, testing accuracy. So underfit, what happened? There are two kind of scenarios. A model is well trained, like this one. Training error is 0. What is happening in this curve? You will see. This is passing through almost all. So in that case, training with error will be high. But in that case, testing error will be less. Too much training happened. This is the example of overfitting. Okay, the time is less. So what it means, any model you are using training and testing part, you do the training, find out the accuracy and do the testing. And if your model training accuracy is too high, like 99% accurate or 90% accurate, but the test accuracy is 40-30%, such kind of model is overfit. During the training you are performing well, means if whatever as a teacher I am teaching and asking, you are doing good. If someone else is asking some different kind of question, you are not able to perform well. This is the overfitting example. So what we do for overfitting, okay, we try to do that, okay. We put the regularization to solve this issue. Another way is that underfitting part. For example, if training accuracy is poor, whatever teacher I am teaching, and if same question or something similar kind if I am asking, and you are not able to solve. So training is also bad and testing is fluctuated randomly you are solving. So this is underfit. You are not trained well. So what we do in that case, we model complexity, we increase linear model ki jagah we will go for non-linear model. This is the linear model, this is the non-linear model. But if you go with too much non-linear, it will lead to the overfitting. Too simple model, it will be the underfit. So what will happen in the machine learning, we need to make this balance. And that's where this regularization term comes out to do this. We don't want overfit, we don't want underfit, we want a model which should be good in the training and good in the testing also. If someone is performing 70% in the training part in the classroom and also 70% success in the real world, that model, that kind of model for the robot are something we want to build up. So this is the regression example. You can see this is what underfit and overfit, and you will see this philosophy in every machine deep learning model, whatever the term you will give, we need to make a balance. This generalization approach is very, very important. You choose any model which you might have heard, but this balance is very, very important to make every machine and deep learning model to be generalized. The same thing you can say in the classification problem. If you use the perceptron, you can see there's two simple model. If you use a kind of model, this curve kind of graph, and this is the, let's look this part. This, if you visually see that this picture, third one, two zigzag curve, but training accuracy is 100%. Blue is in the left, right, and this orange in the right. But if any new data, this one comes out, or this one comes out, where it will go? Very difficult because two zigzag, so easily we can make a fool this model, or this model may be too much overfitting because it's sensitive of the case is too much fluctuation, so it's too sensitive, so it's going to be overfit. So we need to make a balance. Same in the deep learning models also. I will come up at the deep learning, but what we do, the training error and testing error we plot, and then see that this error should be minimum. So validation as well as training should be less. In some cases, training error is reducing, but validation error after certain age increasing. This is the over. This scenario we don't want. This scenario we don't want. We want generalized part. The whole variations of this is how to make a generalized model. If you see, for example, because all these models are data driven, and if data set is biased, something wrong you will get. For example, you have a data, and deliberately I am giving a data. I am giving some points of some images of elephant tail. I am giving you elephant tail. So what will happen? And you will build up a model to classify it elephant or snake. Then what will happen? So if data have some biasness, only you will see the tail image of the elephant, that it may be closer to the snake rather than the elephant. So data should be proper representation of a picture where you are working. If someone is deliberately giving the wrong result, definitely your model is going to perform badly in that case. So data is very, very important to build up a model. Even if data is your next data, how it comes out. I will talk about later on about the distribution of the data. From where data set is coming, because all the deep ML models, we are assuming some kind of statistical assumptions to build up the model. But underlying theme is that whatever we are developing a model, it should not be underfit, it should not be overfit. We need a balanced model to solve the problem. So what we do, we plot that this is the underfit zone, overfit zone. We want a balanced one part. So what we do, we plot the training accuracy, testing accuracy in different setting and see that where the balance comes out. And then we choose that which model is good for our case. So, and also another parameters, there are parameters and hyperparameters in the model. So parameters are the model which you are like weight W, which you are learning from the data is a parameter. And sometimes in many algorithms you will see to run the algorithms, we need some parameters to fix first, then our model learning will happen. So those are the hyperparameters which govern our learning rate of the our model. For example, if you are aware about the gradient descent optimization model, what will happen in gradient descent? Wt plus 1 equal to Wt minus del fx lambda. This is del derivative. So this lambda is hyperparameter. So anywhere if you are going to play the optimization problem or gradient descent to solve the minimization function which I discussed, in that case we have to fix this to learn the weights. So what we do in train, we have a data set, so original data, we split the data in training and testing part. Further, we split the training data, validation data and testing part. We do this part for, we do the fine tuning for hyperparameter, and then we, this is the training data only. This validation data and training data it is used for hyperparameter tuning, but this training and testing data further to choose our model, which model I should choose. So training and test we perform, and then I can say that okay, this model is good, which have the better accuracy, training and testing both, that model we choose. So any machine and deep learning models, we have a data, you have a data, you have to split the data in training and test part, and then you have to develop the training part, this part, left part, and then you go for the testing part, evaluation. So all the learning is happening in during the with the training data. Training is not happening with the testing data, only testing evaluation is happening. And then we measure that whatever the training is happening is good or bad. So this is the process which you have to adopt with every machine learning and deep learning. Whatever the applications, either ANN you are going to use for differential equation, you have to do that. Okay. So what we need to designing any learning models, choose the training experience, mean the data, choose exactly what is to be learned, target function, what do you want? You want to predict the share market value, you want to do the regression, or you want to do the classification. The target function should be fixed. Then target function, how the error you are going to define. The function fx, either support vector or ANN, this fx could be anything. So that should be fixed before with learning, and then we do this training versus test distribution. We assume that our data set is IID. Let's have a talk about what it means. IID means identically independent distributed data. For example, data sets, you can say you have one bucket, okay, and right, you have one bucket and there are some balls, black, this is the red ball, this is the red ball, this is black ball. So you know that in the distribution means every data we have some probability distribution function, so X and corresponding probability. So identical distribution means same kind of distribution. So for example, same means we let it be a box, then be a box. There are 3 red ball and 3 black ball. And if I am saying pick 5 balls, if you are picking 5 balls randomly, so one way of picking is that pick one ball and throw it away. Pick one ball, throw it away. Pick one ball, throw it away. If you pick a ball and throw it away, then what happens? There are 6 balls. If you pick once and throw it away, then after that probability of the remaining ball will change. In that case, picking a ball is not have a identical distribution. In that case, distribution will change. But if you are picking a ball, noting the number, and again you are putting that ball in the box, okay, it was red, R. Again remaining 6, you pick anyone, so that red same may comes out, then again R. So in that case, distribution will not change. And you can pick the ball. Picking a ball means collecting a data. So what we are assuming that for every machine learning models, most of them, not every, that it's identically and independent. Means picking a first ball is not going to affect the picking of the second ball. Means probability is not going to change. So distribution is not going to change. This is what IID kind of assumptions we make. It means whatever the data set you have, we assume that it is coming from a single kind of distribution, and picking a one data is not going to affect the getting another data. So this is independent, and identical means same distribution. So these assumptions make many calculations and theoretical development much easier, and that's why in most of the case we assume that okay, we have a data set which is IID kind of. If examples are not independent, require okay. I'm not going. So tens of thousands of machine learning algorithms, 100 new every year coming. Every ML algorithm has 3 components. That's why you have to have represent. How to represent the data? If there is image, okay, what should be the value? So this representation is like Y, A, B, C, D, E, F, G, H language. So this one kind of representation. In the same way, to do the learning, what should be the proper representation? How the data should be. And this is the big challenge. This representation learning is a bigger challenge. This representation right now you can understand that you are doing with ANN, you are doing with SVM. But this is the problem. This is the representation that if I want to classify the image of any human being, then it becomes to know that okay, I need a representation in the data form so that every face I can recognize, every face on this board I can recognize. Not so easy task. But we need a representation. We need optimization technique, because once you define minimization or maximization function, we need to solve the problem. And for that, most of the time in ML and deep learning part, we use gradient descent. Some application you can see of heuristic algorithms people have used. And then the third one, we need evaluation. So that how to evaluate, how to define that error, how to measure that error. And so for the function, you can see that ANN, SVM, what I said that, and there are so many models. So 3 steps for every machine and deep learning models we need to do. Okay. So later on, what happens? People say that okay, earlier before 2010, most of the works were on machine and deep learning part. And what was happening in this case in machine learning and deep learning part, people say that whatever the image, we need extractor, feature extractor. What should be the taken as the feature of this image so that the classification will build up, either SVM or ANN model. So whole performance of the models were dependent on the feature which we or you have extracted for raw data. If this extracted feature is wrong, model performance will be wrong. So the whole development of initial development, either using ANN, SVM, all were based on this part that someone will tell you, okay, this way you extract the features. So a lot of feature engineering people used to do, and then with lesser number of features, they build up the models to do the classification. What happened after 2010, this deep learning part, what the idea was that if we need one expert to do this feature engineering, can we develop a model where you give the raw data, that model itself will learn the feature and do the rest, do the learning and then output. So this part was later merged in the self network, feature extraction, only give the raw data, give the output. So this kind of, you can say, advent of deep learning happened, and nowadays in most of the application in kind of learning kind of problem, deep learning models are giving state of the art results, but at the same time there are pros and cons for dealing with these deep learning models. Well, there are so many deep learning models, but okay. I will discuss about ANN and then I will discuss about what are the challenges in deep and machine learning part. But one algorithm of machine learning, I would like to discuss artificial neural network part. Then I will go to the deep learning and the issue of safety and security and how we can deal with this. What are the challenges of this model? Because deep learning are giving the more better results nowadays. Suppose, for example, before going to for curiosity, let's put it. Many biometrics are applicable nowadays. Everywhere people are saying put the biometric. And suppose this face recognition biometrics is there in your office, and it was let build up using the deep learning models. And if someone will change the model parameters, parameters means W, then what will happen? Suppose I'm an attacker, and if I change the weight of those model which had been deployed in graphic era, then what will happen? Your automatic system may not be able to recognize that fellow, and that then service will be denied. He or she will not be allowed to come in the office. So why it is happening and what kind of things is there? Okay, that I will tell you in the safety part where the current state of the arts going on. But before that, I would like to cover the ANN so that those who are not knowing can understand that, okay, what are the network and classification could be possible. Then I will connect to deep learning models. Okay. So let's we take 5 minutes break. Then I will start artificial neural network part. And then I will take in between questions also because there are so many things, but I will not go in too deep, but the question comes out accordingly, I will go. So we may take 5 minutes break and then I will start 10-15 minutes about artificial neural network and how it works before going to the security part. Is it okay, Dr. Anju?
Yes, sir. Yes, sir.
Okay, so any in between, if you have a question, write it because maybe I don't know the audience.
Yes, you can write on the chat if you have any
query. So just I will take 5 minutes. I'm here only. It's 8 o'clock, so I will be here at 8:05. Okay. Sharply at 8:05 I'll to start again.
So if any participant had any query,
yes,
so you can ask them. And you can write in at your chat box.
Okay.
Probability is there. Probability ऐसी है हो सकती है ये बोल रहे हो
So I may start now. Okay. Hello everyone, am I audible?
Yes, yes.
Okay. So I may start now, but I will go with ANN. So artificial neural network and how it works. So I will go through the board first and then I will connect to other part. Is it visible?
Yes, visible.
Voice is very low. Yes, okay. So I will use the board first to describe ANN, then through the PPT. And then I will connect to the other. What is happening in, I will talk about artificial neural network. Very famous word and many times people are using for even differential equations and all, but I will talk about. So what is happening with ANN, that I said that if we have a data set X, let some more feature if I am saying X1, X2, X3, 3 picture and corresponding Y value. I'm talking about the supervised model. So every data have this much component. You can say Y value is T. What we want to build up, we want a model fx, or you can say that this is T so that representation will be same, or this is, you can say Y, a model, let remove Y, otherwise there will be confusion. What we want to build up a linear model first, W1 x1 plus W2 x2. I'm writing a linear function plus W0 weight. Or you can say I can write W transpose X in the vector form. Or in the pictorial representation, what I can write the same thing as this is your X1, this is your X2 feature, this is your X3, and this is the one biased term X4 or X0. This weight corresponding to this, you can say weight as W1, corresponding to this W2, corresponding to this you can say weight as W3, and corresponding to this you can say W4. So this is your, this part is your Y or fx, whatever the name let. I'm saying Y here as fx value as Y. So Y equal to fx equal to W transpose X, this node. So simple linear function, what that function which we use for regression, we can write in this function form. Okay, later on what happens, people develop this, using this people have developed logistic regression, and what they do, they passes through exponential function or sigmoid function, that is you can say e to the power sigmoid function, they 1 upon 1 plus e to the power minus x. This is a function, so you can say minus fx. They passes this whole fx to this function. So it converts every value between 0 to 1, so it becomes a problem as a probabilistic model, a logistic regression, and then you can say if 0 to 1, you can say greater than half in one class, greater than less in one class. So this one was initial linear logistic regression was built up using the linear regression, this linear function W transpose X, then passing this sigmoid function, which is also known as activation function. What we do through activation function, we convert this function value may be anything, but we normalize between 0 to 1, or in some using different kind of activation, we can normalize in a different domain. So, but this linear problem, this logistic regression problem was not able to solve all the issue. So then later on people say that, okay, if this is one node, you can say, and let it be clear this part. Then okay, now I am clearing this, so we all are agreeing. What people say that, okay, if this is the case, can we build up a model like this? Okay. They build up, okay, they say that let this one you pass through yours. This is y. You can say this is your sigma y, means activation function. Okay, after activation function, you can say this is your y1 or z1, whatever you want to say. And they said that, okay, you get one more node and connect the same data set like this. You can say this is y2, then you pass and get z2 as sigma y2, and then this is now two node, and then they connect again as one node, and you can say final target or whatever you want to achieve. Here you can again assign some weight. So initial single network which I have designed using logistical problem is not able to solve all the issues. Later on people say that, okay, using the same data you build up multiple nodes this way, y1, y2 or y3. And then you connect to the output layer. This is the output, this is the input, and this part is basically known as hidden layer of ANN. So what they said that instead of single logistic regression, which initially I build up this part, they build up multiple logistic regression and connect it. And that's what this form of ANN comes out. And they said that, okay, instead of a single feature connecting to the output, it may not be sufficient to get the result. So they connected multiple such nodes, and then they connected to the output node or one more node. So basically stacking off one perceptron, one logistic to another one, and then they have made a bigger network. And that's what we do in artificial neural network part. So just give me one more slide I have kept for this discussion, then I will come back. Okay, is it visible? So basically the idea of this is the idea of artificial neural network. It's gradual development. It's not what the flow people have developed ANN. They develop perceptron, and then there's a logistic regression. And then they say that single one is not able, this single one is not able to solve all the classification tasks. Then they combine like the same initial data, if you see they save, and then they combine multiple kind of things so that different features we learn, important features which help us to classify or learn the task which we want. This is the general structure of artificial neural network. Though people said that it is inspired from the human brain, what is happening from the brain, any information if you are taking it, we don't know how it is, but it connects, it gets from multiple nodes. Many neurons are there in the brain, but it is not exactly the same human brain, but initially people thought out as that it's inspiration of the human brain. So what I said that the same thing here. For neural nets, we use much simpler model like neural nets. So what we are doing, this what I already said that a simple connection of W transpose X. This is the W transpose X. Y is a W transpose X means Y equal to W1 X1 plus W2 X2 plus W3 X3. This is the output. And we pass this through this phi as activation function. I use a sigmoid function, this one. This is W transpose X plus B bias. I use this as X naught, or you can use as a B. So many notations are there. This is the bias term. Like in a simple equation, what we do in linear equation, we put Y equal to MX plus C. So same way we are putting it here, this bias term here. And then in the logistic regression, we pass through the sigmoid function. So what it does, it converts the value 0 to 1. Y value is between 0 to 1. But once between 0 to 1, this probabilistic model is ready. If you get above 0.5, you can say in this class, below this 0.5 in that class. And this is what simple logistic regression. And then by throwing together lots of these incredibly simplistic neural like processing unit, we can do some more powerful computation. That's what it comes out, multi-layer perceptron. The name of artificial neural network is multi-layer perceptron. Also, it is a misnomer basically, but the name what the currently we are using, it's a multi-layer logistic regression we are putting. Oh, already I discussed. This is the structure of a feed-forward neural network. We have input. We may create one layer of nodes, another layer of nodes, and then output layer. This is the output layer. So this is the input layer, what exactly the data sets. Then the first hidden layer we may, as a parameter, we have to hyperparameter we have to fix. We need 3 nodes or 4 nodes or 5 nodes or billion nodes in the first hidden layer. Then we want only one hidden layer or multiple hidden layer. So in general, we go with the single hidden layer or sometimes we go with the multiple layer. But keep in mind, as the number of nodes you are going to increase, number of hidden layer you are going to increase, and then you are connecting each one to everyone. So number of unknown parameters W are also going to increase. So this is the, later on you will see the issue, but this is the general structure of artificial neural network, and you will see in many applications this ANN is giving huge success in multiple applications, later on deep learning also, but this ANN is what about have this input and output layer, and then in between hidden layers you have to fix how many hidden layers and the nodes of the hidden layer, and then your multi-layer perceptron is ready. This is typically a directed acyclic graph, and this gives a feed-forward neural network. This is the way we are going. A feed-forward neural network. A simple feed. This is the structure, and there are many multiple ways to solve. This is the fully connected, means each node is connected to all the above node, or each node is connected to all the previous node. This way you can say. And I said that activation function, this phi r sigma, very famous, you all are knowing might be, is activation function as a sigmoid function, which I discussed. This one, this graph is a sigmoid function, and this is inbuilt, or most of the time people go through with this. But as we move to the NN part and more deep learning, also this is the extension of NN. You will see lot of may get 40-50 number of activation functions. So most famous one is that soft ReLU and ReLU for any function value, how we convert between 0 to 1 or some range, so that we can perform our task, either regression or classification, whatever we want. This is the also important part in the neural network. There are so many. This is logistic regression sigmoid function, which I said that most of the time activation function we use logistic. Okay. And in the output layer, if in between layer node, each hidden node have, or in output node have this sigmoid. But output layer only we can use as a softmax, either sigmoid, this one, or softmax. But in the input layer, you can input node, you may use any other node, any other activation function at a node to get the output value. So this is the multi-layer perceptron models, or ANN. This is another name of artificial neural network, how we can build up. And then we, again, what I said, that we need to define the error, and then we learn these weights through the gradient descent or back propagation, one of the famous algorithm for this to solve artificial neural network by using back propagation model. So this way, once the model is built up, we can solve this at the time constraint. Okay. And one thing I will tell you about the fact that it is a universal approximator. So ANN you can use to approximate any function. So ANN if I am saying that any function, it means you don't know which one, n number of nodes in the at the hidden layer, but it may have the power to approximate any function if you want in a data set you want to approximate. Okay, you can do that using nn, but the number of nodes and that part you have to simulate and you have to do the study and find out okay which one is suitable for a particular application. So it's a very famous theorem, and that way multi-layer feed-forward neural nets with non-linear activation. Okay, it's not activation only, it's a non-linear activation function which is making as a non-linear model, and it's a very powerful model. It's universal function approximation. They can approximate any function arbitrarily well. Any function x to t, if you want to approximate, you can use using the non-linear activation. This has been shown from various activation functions, so most of the time. And this, due to this property of universal approximation, people are using this one also. It's not the wise always to go with this, but if any simulation study, if you have the late data sets and if you are assuming that okay this kind of a differential equation or some models are there, even in that case to get the approximate solutions through this approximation, you can use artificial neural network to solve this problem. Okay, so this is, I will not go in detail, I will come back to the other part. This is what artificial neural network is. So after that, what happened, people have deployed this, and then people have said that in the deep learning era, what will happen, that people have tried one fully connected network I have shown, but people have tried, okay, let's multiple connection. Why unique one? They said that, okay, let's go with the multiple connection to multiple kind of network you can design. And which one is suitable for a particular application? That's what the advent of deep learning happened. And in deep learning, lot of, it's not a unique way. People have designed so many algorithms in deep learning. It's not the unique way. So you can say discriminative model, generative models, and hybrid architecture. One quickly I will, because most of the people may be from mathematics, I will tell about discriminative model and generative model. Means what people say that in the discriminative model, you give me data and y, and I will learn directly that function using ANN or CNN or any model. This is the discriminative. But what generative model is saying that okay, if we have x, we have y, then I want to learn this x using the Bayes theorem. I want to learn the distribution of x first, and once I know the distribution of x, then what they said that first I will learn the distribution of data and label. So this one you can say that fx into fy by x. Those who are knowing the product rule, I can write. So what I will do, I will learn this distribution, and then I will learn this x and fy by x, and then sorry, this y, I will use this one, y and x by y. Sorry, beta. This is getting 1 minute. So basically Bayes theorem comes out to learn this fxy. What say this is equal to fy into fx by y. People say that from the data I will learn this distribution, and then I will use Bayes theorem, means to get this, what will be the label for a given x using this into this fxy. So learning the distribution means from where this data set is coming and then deriving this using the Bayes theorem. Basically, this is what the generative model. So there are two kind of models in the machine and deep learning. One is generative and one is discriminative. Discriminative is not bothered. We just assume that it's IID kind of data and build up the model. In generative, we said that we are interested to know the distribution, and then we apply the Bayes theorem on that, and then we tune up our model based on the Bayes theorem to get it. This is what the generative modeling. There are so many methods for that. Okay, so this is all about deep and machine learning. So it comes to the safe machine learning, and what I want to convey that nowadays we are deploying this ML and DL in many applications. One application I said that biometric applications, autonomous car driving, and everywhere people are thinking to apply this deep and machine learning. Even the doctor diagnostic, you can see that, okay, I can predict that if something is happening, any diagnostic model, either car diagnostic, human body diagnostic, people are deploying. But the issues are, what are the challenging part of deploying this machine and deep learning models are, the first thing that is security. There are two kinds of security. One, we have to secure our data. So data privacy is very, very important part. So like that even each individual data sets, like whatever you are doing the shopping through Amazon and Flipkart right now online, all data is with Amazon and Flipkart. Whatever the policy at this country level is currently, but they have. If they throw this data set in the market to everybody, then okay, your privacy may be breached, and after certain times anyone can predict what next you are going to do, and it will happen down the line. Just they have 5-6 year data. Just imagine after 20 years, every time you are buying through Amazon or online shopping, each one have the data what next kind of purchase you are going to do, and so they may be used or misused. So to the data, that part which we are sharing to everyone, the privacy of that is very, very important. This is the data privacy. Another important part is the privacy we want the model. Once you build up the model and if you deploy physically that model somewhere for giving a service, and if someone will disturb that parameter, then performance of your physical system will be degraded. So that security is also very important. So there are two kind of things is happening which security is important. Security of the data, security of the model itself. We have developed a model for a security, but that security of the model itself is also important. If someone will break some way, attackers can destroy your model parameters, then the performance will degrade and then the service will be denied. So the security of data set as well as security of the model, both is nowadays in the currently we are connected so much in the world, is very, very important. And this is the important issue. Some examples I'm coming to that. Another part is coming what people are thinking that whatever you are doing and predicting, the model should be accountable or explainable. For example, if someone is saying that some person is going to have a particular disease after 5 years, who will believe? Everyone will ask why you are saying, what are the symptoms will be developed so that you can say down the line after 5 years this disease will be for that fellow. Who will tell you? If you say model is maybe correct and giving that, okay, what the historical data yours is saying that after down the line particular 5 years a particular person A may have a cancer. But if you will not give the explanation, who will? Then people will say you like a Jyotish, you are saying that looking at the hand I am saying. We need explainability of the model. As the model is growing deeper and deeper, deep learning model we are building, we have billions of parameters of those. And making them accountable and explainable is nowadays a big issue. And that's why one of the challenge, health domain people are not accepting as it is these models because they are looking for explainable models. So nowadays accuracy for task has been achieved. People are looking how to explain why it is happening for a particular case. So two important issues, someone is attacking to make the model, then as a researcher job is to make the model safe. Another way is that if someone is giving the output, why it is, which weights, which data set, which feature is important and giving the cause of this particular output. The accountability and explainability is very, very important part in this. So safe part is accountable and explainable. It should be fair enough. So one famous example of this US data set, what happened, black and fair people, black and white people in the US. So what happened that most of the people, rich people are the white people, and they went for, and most of the poor people, most times and not all, was for the black. So they went for the loan, but the system, the machine learning and deep learning model had denied the service. Okay, no loan. Everyone is, instead of looking at the feature, what that model is seeing that that person is black, so don't give the loan. So is it fair? So fairness comes out that way, that each one should be have the fair and equal importance. It's not the color. And then the bias, unfairness for a particular person should not be happening. Same way, in India, we are less, maybe down the line 5 years will develop. In US, they are deploying for the undergrad admission and grad admission process also. So if you are designing a machine and deep learning model to select that, looking at your CV and all record that fellow is good for a particular course or not. But it should not be that, it should be biased towards boys, not towards girls or something else. It should be fair enough to represent the case. This is also a very, very important. Wherever you are deploying the model, it should be a fair one. It should not be the bias toward a particular class. This is the also important problem. And then another one, ethics. Ethics comes out in that it's a big debate, and where you are going to apply this ethical ML and all. Each country may have a different ethics. So based on the societal and the country rule, you can say how we can make a model to be ethical enough to take the actions. So this is the fourth pillar, or you can say safe machine and deep learning part, where nowadays researchers are looking to design to solve the many real world problem, because the moment from the development, people are going deployment of AI/ML model. These four important issues needs to be taken care. So let's back to this safe security part, which I want to cover. I have a solution, but okay, I will come. So the basic assumptions, what is happening in the basic ML and deep learning part, wherever you are applying, we have observed system, we do the data acquisition through sensor or manually. Then if we do the feature extraction, this and training and classification, this part is what the machine learning route. And in this feature extraction directly, if you are doing to the models, this is the deep learning route. Okay. What are the challenge? Nowadays, people are talking about the deep. And the deep learning, what ANN, you have seen that in the deep billion number of parameters comes out. But what are the challenge in the deep learning model is big network. And the moment you design a big network, huge number of parameters are required. Then we need large computing power, more energy consumption to compute. So nowadays people are talking about you are designing a big data algorithms, but at the same time, how much energy is required for that algorithm? That also is going to be count if everyone is talking about the green energy revolution. So in that part, sometimes accuracy, and we say that we need this much computing power to get this result, but what is the cost of that? So energy consumption is people are taking also one important challenge as the data set is growing, as the big deep learning models we are going to deploy. And if models are so high, parameters are so high, we need a big data set to require. So these are the challenges for every deep learning models. How to learn big networks. Gradient descent is going to fail. If yes, then how to solve. There are variants of algorithms how to deal with. Prone to attack. This part I'm going to cover. As the model is going too deep, more prone to be attacked by a fellow. And this is the one of the important issue that nowadays deep learning models are giving so success in the state of the art, but at the same time, much easier to fool them. So how to do that? I will come to that part. Rather than then later on, I will come to the low resource and transfer learning part. Though I have put it first, but I'm going the part so that I will connect to you. Sorry for instead of more advanced level. I will connect to that security part first. Just a minute. Yes. Security part, and then I will come back. So already I said that surveillance, anomaly based, self-driving car, If self-driving car you have trained using deep learning model and someone is easily going to attackers, then what will happen? This will be disastrous. If autonomous car and someone will, because if automatic, so its network is corrected and someone can change the weights, anything, a terrorist attack through this autonomous car might be possible. So all these are very, very important issue, cancer diagnostic, what I said and all. Let's see one example so that you can understand very easily. The use of ML noticeably, especially deep for security application, has been rapidly increasing. People are deploying malware detection, multimedia forensic, biometric based authentication, traffic analysis, static analysis, network intrusion. So there are so many. Little attention has been given to the security of machine learning. Yet fooling MLDL system turns out to be easy task. We are deploying, everyone is saying deploy, this will happen. But at the same time, there are attackers which can easily fool those models. So these are the one example which I will show you. What attackers are doing. There are many kind of, this is white and black box attack, but attacker is aware about ML tools. Independent assumption does not hold tailored noise. So there are attackers which I am seeing, like I am an attacker. I am seeing your data. I am seeing your observed data. Then I am seeing your deep learning models. And then I am seeing your training algorithms and classifier. You may make save your data. You may make data acquisition. But there is a possibility that you can see data and weight and models, and then you can do the attack. This is a white box. And in some case, only input and output you can see what the output or model is giving. You are not able to see the model, and then even in that case, attack is possible. So this is a black box attacks. So for example, if you see this case, what attack means, you want to do the classification. And in that case, what I can do that, change input slightly such that it remains in A but is classified in B. So if I know this boundary means you can say if I know W transpose X, this is the boundary. Let's for example, if I know this, and if I know the data sets, what I will do, I will change this data set some value so that it will come to here. Label is same, but because value are 2 or 3, you can say I will change this to 4 and 3 like this. So data set, even though you were knowing that this is the malicious, so some feature value it will change so that it will be classified as a original one. If I am knowing that, just simple modification. If I know the boundary, if I know the data, then I will not do the changes in this direction. If in this direction I will do the change, it will be again, if it is a malicious, it will remain the malicious. But if I know the boundary and if I am intelligent attacker, then I know that doing minimum change, how I can fool this system. This malicious will be classified as a regular. This is the one misleading machine learning. So just we are changing minimum change, and but it is classified as a wrong. So mostly what is happening in the boundary points, what we do at the boundary point, we just, this is the data poisoning. This one was the data altering, just changing the data attack. This is data poisoning. For example, if you are suppose classifying cat and dog image, so someone can change even though it's a cat image, but the label person is changing. Label saying this is a cat image, but label you are saying now this is a dog. This is another kind of attack. And this will also misleads the model. This data poisoning, some poison we have added. So wrongly data label we are giving. So this will also. Sorry?
You have shared any screen?
Yes, I have shared.
No, but this time this is not visible.
Oh, you have not mentioned. Okay. I thought. Just a minute. Is it visible?
No.
It's
Yes,
showing,
now it's visible.
it's showing to me. Not visible.
Yes, now it's visible now.
Yes.
Okay. Okay, so I will just start from here.
I thought that you feel like that.
Okay, I thought.
Now it's visible.
No. That's what in online mode sometimes it happens. So what I was saying that attackers can change some intelligently some value of this data sets so that it will be wrongly classified. Same way poisoning means already I said the example that some labels you just change and so that attack is possible and this model will perform poorly. For example, this is the deep learning models. Okay. And it was trained to classify lion, car and street light. And if you see the accuracy, lion accuracy 0.99, race car 0.74, traffic light 0.9. Then what attackers did? Some value they have changed, the data they have changed. Poison, so some value they change for this image and also this image. But what is happening? Visually you are seeing it's still lion. Through naked eye you are seeing that no, it's lion, but your deep learning model while predicting is a pelican. This is the car. The pixel value they have changed. Attackers have changed in such a way. Now it is showing as a speedboat and this light as a jeans. But visually the attackers, human eye you cannot make full. Human eye is saying this is a lion. This is a car, this is a street light. But this model, by changing this small changes, lion is predicted as pelican, speedboat, this car is predicted. The attack has happened, the model is same, but performance has been changed. The classification has been changed, but human eye, still it is saying no, it is same thing. So this is one kind of attack. So something which is lion, you can make this full. Easily, deep learning model is now full by using some change, some values. And if you see that the change difference between that, the attack, image after attack and original image, you cannot visible what the changes they have done. Human eye cannot see the difference between here, something you are in the second image you can see that it's something is happening, but it's not meaningful from human eye. But that information is meaningful for model. Model just by attacking, just changing some value, even though human eye is saying some attack is visible, this is the car, but our deep learning, our machine learning model is going to predict as something else. So this is a kind of attack. So this is very much needed to solve this. And currently you can, maybe people may look at this. This is the one problem to make a secure ML and deep learning model. For example, just see this problem. Detection and recognition are usually pipelined. As a detect, you just detect where face is, so there is a face detection. And for that you can build up AI model, MLDL model. Once the face has been recognized, then you have to classify that that face is detected. Then you have to classify it is a Brad Pitt or Carnegie or Harrison Ford. So what is happening? This kind of model, you can say facial biometric system. What I said that this model, if you are deploying at any offices, highly secured offices are there where people are not allowed without identity. Every day people are allowing through the identity only. And if you are putting this biometric system, there are processes how to make safe. But if you're deploying MLDL model here, then person can attack this part also, the model itself, or they may, if someone is changing his her face little bit, then this may not be recognized, face may not be recognized well. some small changes then may not be recognized. So how we can make this model safe enough so that the first thing should be recognized, and here also machine learning model face recognition is a different model. So if any small change also, but original person should not be denied the service. But at the same time, false one should not be allowed. Means you are classifying that the lion is allowed to go, but someone dog image, human eye is saying dog, or some pixel change, you do that and it will be classified as a lion. Then the story will be dangerous. So security, it comes out in this way. You can say attackers can be a harmful if you are deploying the deep learning parts, a deep and machine learning part. So this is the one problem which you may look at how to solve that, and there are solutions for this one also during the training purpose and all. There are process how to solve this issue, especially to get this part to be done so that attacks can be minimized. It's like a game theory. So developers are developing the models and attackers are doing attacks. So it's not that one model will be safe against every attack, but at the same time, designers are developing the models which are more robust. Whatever the attacks right now possible, and the same time attackers are designing new attacks. So it's like a game theory, one was going up, up, up. So it will go on. So the idea is that once we deploy in the real world, it should not be harmful for the society. So this is the one of the important issue for this. So there are solutions to deal with that. We work on that around this part also. But okay, some solutions are there. Possible is differential privacy and all, so that attackers may not get the weight. But okay, this part I will go one more so that you can understand. I want to discuss those parts first. Then one possible solution is, then I will come back to that part. Data security. So nowadays, what every country is saying, even India is trying, had tried, but still it's not, to Google and Facebook that okay, you make data storage in India only, or so that data cannot be shared to anybody. If data will not be shared, there are pros and cons. For example, health data. We all are visiting in a different health hospital, and most of the time that data is with that hospital. We are not sharing with. They are not sharing most of the time. So what is the drawback if data is stored and no learning model is developed? Might be the case that some hospital have very less data. So that cannot be machine and deep learning model will be developed. So data we kept it and we will not utilize for learning. Again, a problem that it may not be good for the services. But at the same time, if I am deploying for the services in a different application, but then my data should be secure. My privacy comes out. So what people in the last 2 years have built up and bring it this problem I gave federated learning, borrowed from federated structure of governance, is that there is a server. Look, I am a person and I have a deep learning models, but I don't have a data. And I will connect to each hospital. Node 1 is one hospital, node 2 is two hospitals. These two may be in Allahabad, this may be in Dehradun, this may be in Delhi, someone will be in Bangalore. And what I will do, this data model, deep learning structure, I will share to them, to this. They have data, but they have less number of data. If they will share in one place, then huge data will be there and model performance will be good. But at the same time, if they will share the data in one server, the chance of privacy comes out. To make it confident them, okay, don't share data to me. You keep your data with you, but I'm sharing the model to you. You share the weights of those model to me. Data will be kept here. So data privacy means no one can attack, and that part one way we are saving. By the way, because if once we will not share the data, the breach of the data sets security will be very less. So how to develop a model in such scenario so that data will not be shared. Parameters means W will be shared from this, from this, from this and this. Then it will be average and then it will be reshared to again use this weight and this cycle will go on. This is what if the data sets are at the multiple. Suppose cancer data sets, some radiologist data sets. Even if in Allahabad, if I will say how many, there are so many, but those who are visiting in the hospital, doing the X-ray and all the things, hardly some data sets will be available. But at the same time, if I will connect to all the cities, Lucknow, Allahabad, Dehradun, huge number of data. So what I am saying, you keep just system with them and I will connect you, but through the weights, and then I will try to learn the weight so that the privacy of the data will be secure. But at the same time, a model will be built up so that accuracy of the model performance will be improved. Each one will have a confidence and then we will get a better model to predict the accuracy. So this is the federated learning setup, and nowadays most of the industries are trying to build up their federated learning setup in the health and in many other applications. Okay, each one have a data. If someone will develop a model so that it will work on your mobile set, then definitely you will be agree that okay, give me a model I will train and I will share only the weights, I will not share our data. So person can participate in this and then this model will be helpful. So this is the one. It may not be secure for all kind of attack, but data privacy will be preserved here and security will be built up. So recently what we did that, recently we just with my MTech student, I did this federated learning setting for multitasking and especially for the health data only. And what we did that again, some data set, suppose chest X-ray data set is available for pneumonia data and this one is the different node. They all are not at the same location, but they're different nodes. So we build up the model and using the multitask, another kind of machine learning. And we found that okay, this accuracy is, this kind of model is good one, and sometimes it is complementing to each other, even though it's different places or data, different have data sets, and these are complementing to each other. And sometimes it may be giving a better result if all data sets are available at the source. But most of the time it may not, because if all data set at one place, definitely the model will be trained in the better manner. But data set is not coming in one place, then how we can handle this is what the federated learning setting. And so prototype we have built up, but it could be helpful for deployment at the health domain, and maybe in down the line 4 to 5 many industry will come up because it's coming. Another kind of problem is in federated learning is coming that many people like you are suppose data sets, KP-Singh data set. If I am doing the credit card, I am using, so I am doing the shopping part. Same, if I am using Allahabad bank credit card, so I am doing a lot of activity purchase and all. The same way I am going in the bank and I am doing other kind of services through bank, and the same way KP-Singh data is at the health domain. So as a KP-Singh have a different features at the different location, but each are not connected. Just think out that my data is with some kind of credit card, some kind of bank, some kind of service provided like IRCTC, some kind of data. My data is, my shopping data is Amazon. So single person have a multiple location data. Somehow, if we develop a model to understand KP-Singh behavior, still till now they are not connected, but down the line people will connect this model that okay, you connect a model such a way so that the privacy of KP-Singh will not be breached, but all the data should be utilized to get a better model to understand KP-Singh. So KP-Singh purchase, historical behavior, and what next kind of thing. So as per the need, company may say that okay, this fellow need this kind of insurance or not. So many applications this industry people may borrow and bring up. So this what I am highlighting, that this is another way of looking, and many industries coming to look this issue to solve the problem. So this is for federated learning setting part. This is very important, and one more part which I would like to highlight, because if anyone have a question then ask, then otherwise I will connect to this transfer learning phenomena. And then I will stop my talk for today. So what transfer learning is, because there are so many things, but people, as per the what is happening nowadays? What happened with the human brain? If I know any computer programming, and suppose C, we studied in our during PG is C++. But if anyone is knowing any language, and that fellow you ask, now you learn a different language, different programming language right now I'm saying, and you may infer with anyone, then human mind is easily adopt, and with certain kind of study he may get the better understanding of the programming. What happened with the machine learning and deep learning model? One data, do the training, different data, again do the training, third data, again do the training. So the knowledge has not been transferred. So what transfer learning is saying, initial model was do the data sets, learning model 2, model 3 means just change the data set and do the learning separately. What transfer learning is saying, do the learning here. If new data set coming, whatever you have learned here, adopt in this domain. Rather than doing the learning from the scratch, we can, whatever I have learned, if new data set is coming, whatever the weights value is there, we do the fine tuning of those weights and we can transfer the knowledge. So this is what the transfer learning is, and this is what people are thinking to build up this lifelong learning model. The idea is as human incrementally doing that. So new thing is coming, you build up, we scale it out. We don't learn from the scratch everything. We every time whatever the knowledge we have, we build up on top of that. Same idea was borrowed for, and the idea was that one model you have learned in one domain, another domain comes out, okay, just adopt in that domain, another domain comes out, adopt in that domain. And in this way you transfer the knowledge from one domain to other. There are so many categories for this. How to do that? What are the conditions in that? Recently, one of my PhD students did this, just graduated 4 days before, on this transfer learning for low resource environment. So what I'm saying that this is the important issue, because and most of the researchers nowadays are using transfer learning. We don't have that computational power to perform, even if we don't have the data sets and computational power to perform all the models training from the scratch. So most of the person, I'm not saying all, what we are doing, we are borrowing what RNN or CNN has been developed by the either NVIDIA or Google people. We tuned up those, fine-tuned those models with our own data, and that's what this is a kind of transfer learning which we are using. So those who are in that domain they may explore. Looking at the time constant, I may not go in detail on that. This is also a very, very important part. So there are so many things in that possibility, but little bit, I'm not going to cover that parts, and I would like to stop here and this, and better I will take some quick questions. Come up with this. So what I can say that, okay, we need lifelong learning models like human. We need ethics in practical applications. So machine learning to be ethical. We need fair AI and secure. Maybe blockchain could be a solution, but still I'm not working on that, but it may be in future. Blockchain as a security for deep learning and machine learning. So with this, I would like to thank Dr. Anju for inviting me, and